So, I have been having some issues trying to explain it. I thought that I could make a good animation, draw some pretty diagrams, but then I realized that I don't have the necessary skills for animation. I'm still trying to learn it, but I'm afraid that's going to take some time. So, I can just give the cliff notes. Every element has its own atomic mass number. This is the number of protons and neutrons that uh, there are inside the nucleus of the atom of the element. Atoms, if you are not sure, they are the smallest possible particle people thought that you could split something into. Nowadays we can split them into further unstable particles like quarks, but that's not usually something that sticks around. What we have out there are atoms and elements. Now the mass of the element is the mass of everything else inside the element. Technically, the electrons count too, but the electrons are just so light compared to the protons or the neutrons that they can just be ignored. Thing is, protons and neutrons have a standard unit mass of 1. So the atomic mass is approximately equal to the number of protons and neutrons. It's not the exact number, it's like the proton is slightly heavier than the neutron. Sorry, it's the other way around, but it's like 1.07 something standard units is the mass of a neutron. uh, 1.03 something is the mass of proton. Anyway, approximately the number of protons and neutrons is the atomic mass of that element. As long as you are not try to think carefully about it, and the lightest element that we have just has one proton in it. It's hydrogen. Now hydrogen's everywhere, really. You can find it anywhere, almost anywhere. The thing about hydrogen is that it's a primary fuel source of stars. It's what most main sequence stars fuse to form helium, and the energy that the helium gives off is enough to overcome the force of gravity. Now, when the stars, start running out of hydrogen in their system, they start fusing helium together. Well, the stars, when you run out of hydrogen, less energy is expelled by the fusion process in a star. So the star kind of contracts together, which kind of puts more pressure on it and enables helium to be fused to form, I think it's boron, but I might have to recheck the periodic table. But it's one of the element. It's element 4. Don't think it's boron. Whatever it is, it's being produced there. So you have helium fusing to element 4, then you have carbon, boron, oxygen, all fusing in this process, and this goes on until you have iron. After iron, the fusion process is no longer viable. That means that the energy that the fusion process gives out is less than the energy it took to get the elements to fuse. So at that point, the star just kind of explodes if it's big enough. If it's a supergiant star like Betelgeuse, it's going to explode in a supernova. And in those places, the conditions are perfect that they can form heavy element like gold and silver. And uh, obviously those things don't happen all the time. They only happen in big huge supernova explosions, whereas hydrogen is just there in the universe all the time. So that's the reason why hydrogen is more abundant than gold in the universe. Now, originally, I planned to, like I said, draw a diagram showing what happens at the star, but I'm afraid I'm not far along in my journey to do that yet. Oh, some exciting news. I'm starting my master's officially from tomorrow. Can't wait. I have differential geometry as my modules. I looked at some lecture notes, and it seems like we're going to be revisiting Green's theorem and tangent spaces. Can't wait to learn more about those things. I mean, on one hand, I am scared they do sound difficult and I don't understand a lot of them, but I have to console myself that that's all right. That's supposed to be expected. I haven't completed this course. I just began it. So yeah, can't wait to get more into it. If you want to follow me on my journey, don't forget to like and subscribe. And I will see you soon. Bye for now.